Desert Training Range, Western China, 2004. A Chinese Su-27 fighter screamed overhead at 15,000 feet, its pilot preparing to drop a laser-guided bomb on a target bunker 5 kilometers away. On the ground, a spotter illuminated the target with China's new Type 06 laser designator, the reverse-engineered copy of America's legendary ANPEQ system. The pilot released the bomb, which immediately went ballistic, missing the bunker by 200 meters and impacting harmlessly in empty sand. 6 more attempts, 6 failures. Not a single bomb guided properly. Investigation would reveal China's laser designator couldn't maintain a stable beam, couldn't handle atmospheric conditions, and had been fielded despite engineers knowing it was catastrophically defective. This is the story of how China's attempt to steal American precision strike technology became a national embarrassment. The revolution in precision strike. The development of laser-guided weapons in the late 1960s and early 1970s revolutionized aerial warfare. Before laser guidance, hitting a specific target with bombs required either dropping from very low altitude, exposing aircraft to defensive fire, or accepting that most bombs would miss by hundreds of meters. An entire squadron of aircraft might be needed to destroy a single bridge or bunker. Laser-guided bombs changed this calculus completely. A ground-based or airborne laser designator illuminated the target with a coded laser beam. The bomb's seeker detected reflected laser energy and guided toward it, achieving accuracy measured in feet rather than hundreds of meters. A single aircraft carrying a single bomb could reliably destroy point targets that previously required multiple sorties and dozens of bombs. By the 1990s, American forces had refined laser designation into a precise science. The ANPEQ family of laser designators, portable systems that ground forces could carry, enabled precision strikes anywhere soldiers could reach. Special operations teams operating deep behind enemy lines could call in airstrikes on targets with surgical precision. Forward air controllers embedded with ground forces could direct aircraft onto enemy positions with devastating accuracy. The Gulf War of 1991 showcased laser-guided munitions' effectiveness. American aircraft destroyed Iraqi infrastructure, command posts, and military formations with precision that seemed almost supernatural. Television viewers worldwide watched smart bombs enter bunker ventilation shafts or fly through specific building windows. The era of precision strike had arrived, and the Americans dominated it completely. For Chinese military planners, watching American air power demolish Iraqi forces with minimal collateral damage and extraordinary efficiency, laser designation represented a capability gap as significant as any they faced. Chinese air forces still relied primarily on unguided bombs, accurate enough against area targets but hopeless for precision strike. If China wanted to match American capabilities, they needed laser designation systems comparable to what American forces employed. The problem was that laser designator technology involved sophisticated optics, precision electronics, and advanced laser systems that Chinese industry had limited experience with. Developing indigenous systems would take years and require mastering technologies China didn't possess. The solution seemed obvious: acquire American laser designators through intelligence operations, reverse engineer them, and produce Chinese copies. This approach would fail spectacularly, exposing fundamental weaknesses in Chinese precision manufacturing and quality control that no amount of espionage could overcome.
The intelligence bonanza and the hidden complexity. Chinese intelligence operations targeting American laser designation technology intensified through the 1990s, employing multiple vectors: physical acquisition. Chinese agents acquired several ANPEQ laser designators through gray market arms dealers, corrupt foreign military personnel, and exploitation of conflicts where American equipment was captured or lost. By the late 1990s, Chinese weapons researchers possessed multiple examples of American designators in various conditions. Technical intelligence. Cyber espionage operations penetrated defense contractors and military systems, exfiltrating technical documents, manufacturing specifications, and test data related to laser designation systems. Academic espionage. Chinese graduate students and researchers in American universities and laboratories working on electro-optical systems absorbed knowledge useful to military applications. By 2000, Chinese engineers possessed comprehensive information about American laser designators, component specifications, optical designs, laser parameters, coding schemes, and performance data. Program Director Zhao Ming, assigned to lead development of a Chinese laser designator designated Type 06, initially felt confident. "We have excellent intelligence on American systems," Zhao told his team during program initiation. "We know what components they use, how the systems are configured, and what performance they achieve. With this information and our improving industrial capabilities, we should be able to produce equivalent systems within reasonable timelines." But examining the acquired American designators revealed complexity that intelligence data alone couldn't convey. Laser source. American designators used neodymium-doped yttrium aluminum garnet (ND-YAG) lasers, producing infrared beams at 1064 nanometers wavelength. These solid-state lasers required precision crystal growing, sophisticated optical pumping systems, and thermal management to maintain stable output power and beam quality. Chinese laser technology lagged American capabilities significantly. Optical system. The designator's optical train, collimating lenses, beam expanders, and pointing mechanisms required precision optics manufactured to tolerances measured in fractions of wavelengths of light. Surface quality, coding uniformity, and alignment were all critical to maintaining beam quality over the kilometers that laser-guided weapons needed to function. Coding system? The laser beam was modulated with specific pulse codes that laser-guided weapons used to distinguish the designation signal from background laser radiation or enemy countermeasures. The coding system required precise timing control at microsecond scales and sophisticated electronics to generate stable, repeatable codes. Pointing and stabilization? Keeping the laser beam precisely on target while the operator moved, while atmospheric conditions varied, and while targets might be moving, required sophisticated stabilization systems, high-resolution tracking optics, and computer systems to compensate for all these variables. Environmental durability? Military designators had to function across temperature extremes, humidity variations, and battlefield conditions including dust, mud, and shock from explosions or rough handling. Every component had to maintain performance under conditions that would destroy commercial equipment. Each subsystem presents significant challenges, reported senior optical engineer Dr. Lu Feng after detailed examination. American designators represent sophisticated integration of multiple advanced technologies. We can identify components and understand their functions, but replicating them with our manufacturing capabilities will be extremely difficult.
The manufacturing catastrophe. Production of Type 06 prototypes began in 2002, with multiple Chinese facilities attempting to manufacture components. Laser production. The ND-YAG laser crystals proved impossible to manufacture to American standards.
Chinese crystal growing processes produced crystals with inconsistent doping, internal defects, and optical quality problems. The resulting lasers had unstable output power, varying by 20 to 30%, rather than maintaining the stable output precision guidance required, and poor beam quality that diverged excessively over distance. "Our laser crystals are adequate for many applications," the laser production supervisor admitted, "but not for precision designation. American crystals are grown with extreme purity and uniformity. Ours have imperfections that affect laser performance. The lasers we produce work, but they don't maintain stable output or good beam quality over the ranges precision guidance requires." Optical components. The precision lenses, beam expanders, and optical coatings Chinese factories attempted to produce showed quality far below American standards. Surface figures were irregular, coatings were non-uniform, and optical materials had refractive index variations. Light passing through these optics emerged distorted rather than as the clean collimated beam that designation required. "We're producing optics that look correct but don't perform correctly," explained the optical production manager. "Under casual inspection, they appear fine, but precision optical testing reveals irregularities that degrade beam quality. American optical manufacturing holds tolerances we can't consistently achieve. The result is designers with poor beam quality that limits effective range and reliability." Electronic systems. The coating electronics, timing circuits, and control systems showed reliability problems Chinese engineers struggled to solve. Circuit boards were poorly manufactured, components failed prematurely under environmental stress, and the systems showed sensitivity to temperature, humidity, and vibration that American equivalents didn't exhibit. "Our electronics work under laboratory conditions, but they're not sufficiently robust for field use. Connections fail, components drift out of specification with temperature changes, and reliability under battlefield conditions is poor. We need better circuit board manufacturing, better components, and better environmental protection, all of which require capabilities we're still developing." Pointing systems. The mechanisms for precisely aiming the laser beam and tracking targets showed problems throughout development. The motors were imprecise, the encoders had insufficient resolution, and the stabilization algorithms couldn't adequately compensate for operator movement or environmental effects. The result was designers that couldn't keep beams steadily on target.
The testing nightmare. Initial testing of Type 06 prototypes in 2003 revealed catastrophic inadequacies. When tested under controlled conditions against static targets at moderate ranges, the designators showed laser output power varied by 20 to 40% during operation rather than remaining stable. Beam quality was poor, with the beam diverging excessively and breaking into multiple lobes. Pointing precision was inadequate. The beam wouldn't stay on the designated point on the target. Coating was unstable. The pulse codes would drift or fail entirely. Environmental sensitivity was severe. Temperature changes, humidity, or dust would degrade performance significantly. Success rate with actual laser-guided bombs was approximately 15%, far below the 80 to 90% American systems achieved. "We're not producing functional laser designators," the test director reported after initial trials. "The systems generate laser beams that vaguely resemble designation signals, but they don't maintain the stability, precision, or reliability that laser-guided weapons require. Weapons attempting to guide on our designation signals fail more often than they succeed." Extended testing under field conditions revealed even more problems. Atmospheric effects. The Type 06 beam quality was so poor that atmospheric conditions, haze, humidity, thermal shimmer, degraded it to uselessness at even moderate ranges. American designators maintained functionality to 5+ kilometers. Type 06 designators became unreliable beyond 2 to 3 kilometers. Target tracking. The pointing systems couldn't keep beams on moving targets or compensate adequately for operator movement. Designating static targets was difficult. Designating moving targets was nearly impossible. Reliability. Components failed regularly under field conditions. Lasers would stop producing output. Electronics would fail. Optical elements would come out of alignment.
Mean time between failures was measured in hours rather than the hundreds of hours American systems achieved. Environmental durability. Temperature extremes, humidity, dust, and shock from transport or nearby explosions would damage or degrade the designators. Systems that function in the morning might fail by afternoon due to temperature changes. Dust ingress would degrade optics. Rough handling would knock systems out of alignment. These are laboratory prototypes masquerading as military equipment, one test officer reported bluntly. They barely function under ideal conditions and fail regularly under field conditions. Equipping military units with these would be worse than equipping them with nothing. False confidence in designation capability that doesn't actually exist.
The political pressure and premature deployment. Despite overwhelming evidence that the Type 06 was not ready for service, political pressure forced deployment. The program had consumed significant resources over several years. Chinese military leadership wanted domestic laser designation capability to reduce dependence on foreign systems, and the political cost of admitting failure was deemed unacceptable. We acknowledge the Type 06 has limitations, officials conceded internally, but it provides some capability where we currently have none. We'll issue it to selected units with appropriate training on its limitations and will continue development to address problems. Field experience will drive improvements. This decision, to equip military units with systems known to be defective because admitting inadequacy was politically unacceptable, would directly degrade Chinese precision strike capabilities and endanger pilots. Type 06 designators began entering service with Chinese Special Operations Forces and Forward Air Controller units in 2005. Operators receiving the systems were told they had equipment comparable to American designators, providing precision strike capability that would revolutionize Chinese air-ground operations. Reality proved brutally different. Training exercise failures. During the first major training exercises using Type 06 designators, the system's inadequacies became immediately apparent. Of 20 laser-guided bombs dropped during exercises, only 3 guided successfully to targets. The remaining 17 either failed to guide at all or lost lock during flight and went ballistic. We spent weeks training with these systems, a former air controller recalled. We learned the procedures, practiced target designation, coordinated with pilots. Then during the actual exercise, the systems failed repeatedly. Bombs that should have hit targets missed by hundreds of meters. It was humiliating and terrifying. Humiliating because we'd trained extensively and still failed. Terrifying because if this had been real combat, we'd have endangered pilots and failed missions. Equipment confidence crisis. Operators quickly lost confidence in the Type 06. When systems failed more often than they succeeded, when environmental conditions degraded performance unpredictably, and when there was no way to know if designation was working until after bombs missed targets, operators began to doubt whether the systems were worth using. You'd illuminate a target and hope the system was working properly that day, explained another operator. You couldn't tell from the designator whether the beam quality was good enough for weapons to track. You'd just hope and then watch to see if the bomb guided or went ballistic. Hope isn't what military equipment should inspire. Operational impact. Chinese precision strike capabilities, which should have been enhanced by laser designation, were instead degraded. Pilots lost confidence in laser-guided weapons when success rates were so low. Ground forces couldn't rely on precision strikes when designation systems failed unpredictably. And the psychological impact of fielding equipment that didn't work undermined morale and trust.
The hidden casualties and the cover-up. The Type 06's failures were never publicly acknowledged. Chinese media featured photographs of Special Operations Forces with laser designators, and official statements claimed domestic precision strike capabilities matched Western standards. Foreign observers who didn't have access to actual performance data assumed Chinese systems were reasonably capable. But the reality was starkly different.
Within Chinese military circles, the Type 06's inadequacies were widely known and became a source of bitter humor. Type 06 designates everything except the target. If you want precision strikes, don't use Type 06. The only thing Type 06 hits reliably is your confidence. More seriously, the system's failures had operational consequences. Wasted munitions, laser-guided bombs that should have reliably hit targets, instead missed due to designation failures, wasting expensive precision munitions, and failing to achieve objectives. Pilot risk, pilots repeatedly attacking targets because designation failures caused weapons to miss, were exposed to additional defensive fire, and increased risk. Mission failures, operations dependent on precision strikes failed when Type 06 systems couldn't provide reliable designation, undermining mission objectives and operational planning. The human cost was less dramatic than some weapons failures, but still significant. Every operator who trained extensively with Type 06 systems, only to watch them fail during exercises or operations, carried frustration and loss of confidence. Every pilot who dropped precision weapons that missed due to designation failures questioned their training, their procedures, and their equipment. And every mission planner who couldn't rely on precision strike capabilities had to adjust plans, accept greater risks, or modify objectives.
The gradual improvement and foreign alternatives. Recognition that the Type 06 was fundamentally inadequate led to two parallel responses: ongoing development. Improved versions designated Type 06A incorporated refinements aimed at addressing the most severe problems. Better laser crystals, improved optics, and more robust electronics gradually enhanced performance, though still falling short of American standards. Foreign procurement. Chinese special operations and elite units quietly received imported laser designators. Russian systems, European systems, and in some cases, actual American designators acquired through gray market channels. This tacit admission that domestic systems were inadequate was never publicly acknowledged. By the 2010s, Chinese laser designation capability had improved significantly from Type 06 standards, though still lagging Western equivalents. The improvement came through patient development of genuine capability, rather than attempting to copy without adequate industrial foundation. We tried to shortcut development by copying American systems, a Chinese military official admitted in an internal review years later. We discovered that precision electro-optical systems require manufacturing capabilities we didn't possess. The specifications we stole told us what to build, but not how to build it reliably. We wasted years fielding inadequate equipment before accepting that we needed to develop genuine capability through systematic effort.
The fundamental failures. The Type 06 problems stemmed from attempting to replicate precision electro-optical systems without possessing the industrial ecosystem that made such precision possible. Laser technology. American solid-state lasers benefited from decades of crystal-growing expertise, sophisticated optical pumping systems, and thermal management techniques. Chinese laser technology lagged significantly, able to produce lasers that worked, but not with the stability, beam quality, and reliability military systems required. Optical manufacturing. American precision optics involved surface figuring accurate to fractions of wavelengths, coding uniformity maintained across entire optical surfaces, and assembly techniques that maintained alignment under shock and temperature extremes. Chinese optical manufacturing couldn't consistently achieve these standards. Electronics reliability. American military electronics used components selected for reliability. circuit boards manufactured to military specifications, and environmental protection that ensured functionality across extreme conditions. Chinese electronics manufacturing emphasized cost over reliability, producing systems that worked under laboratory conditions but failed under field stress. Systems integration. American designers represented carefully integrated systems where every component worked together harmoniously. Chinese attempts to copy individual components without understanding system-level interactions produced designers where components fought each other rather than cooperating. Quality control. American manufacturers tested every designer extensively, rejecting units outside narrow performance bands. Chinese manufacturers, under pressure to meet production quotas, accepted marginal systems, resulting in designers that varied wildly in performance from unit to unit. The AN/PEQ isn't just a laser in a box. It's the product of American electro-optical excellence developed over decades, explained a Western defense analyst. Every component reflects accumulated expertise about what affects performance. China tried to copy the end product without building the industrial capabilities and institutional knowledge that made it possible. The Typo 6 demonstrates what happens when you attempt precision manufacturing without the foundation to support it.
The continuing struggle. As of the 2020s, China produces more capable laser designators, showing incremental improvements, but reports suggest persistent problems with reliability, beam quality, and environmental durability compared to Western systems. Chinese precision strike capabilities have improved, but the gap between Chinese and American capabilities in this domain remains substantial. The contrast with American confidence in their laser designation systems is stark. American forward air controllers and special operations forces trust their AN/PEQ designators absolutely, knowing that when properly employed, laser-guided weapons will hit within meters of the designated point. Chinese operators have no such confidence, always aware that their systems might fail unpredictably. The economic cost has been substantial, billions invested over 2 decades while producing systems that remain inferior to Western equivalents. The opportunity cost of resources invested in failed development rather than purchasing proven foreign systems or investing in areas where China possessed competitive advantages compounds the waste.
The lesson still being learned. The Type 06 story illustrates truths about precision technology that Chinese military-industrial leadership has struggled to internalize. Precision can't be faked. Laser designation requires precision in every component, optical surfaces accurate to nanometers, laser output stable to fractions of a percent, pointing precision to microradians. Small variations catastrophically degrade performance. Chinese manufacturing could approximate components but couldn't achieve the consistency precision systems demanded. Espionage provides blueprints, not capability. Intelligence operations revealed what American systems looked like and how they functioned, but couldn't transfer the manufacturing capabilities and accumulated knowledge that made producing them possible. Quality matters more than quantity. Fielding large numbers of inadequate designators was worse than fielding smaller numbers of reliable systems. False confidence in capability that didn't exist was more dangerous than acknowledging limitations. Patient development beats shortcuts. The gradual improvement in Chinese laser designation came through systematic development of genuine capability, better lasers, improved optics, more reliable electronics, rather than attempting to copy without understanding. The M24 sniper rifle story and the Type 06 laser designator failure share a common thread.
Chinese attempts to replicate American precision systems without building the industrial foundations that made such precision achievable. In both cases, stolen specifications proved insufficient without the manufacturing capabilities, quality control systems, and accumulated expertise that American industry had developed over decades.
The enduring reality. American laser designators continue evolving, with new generations providing greater range, better accuracy, and enhanced capabilities. Systems like the AN/PEQ-15 and newer variants maintain American dominance in precision strike enablement. American forces trust their designators absolutely, confident that properly designated targets will be hit with precision measured in meters. Chinese laser designators remain what they've always been. Systems that look like precision strike enablers, but can't deliver the reliability and performance true precision demands. They satisfy political requirements to claim domestic capability, while delivering performance that forces operators to doubt their equipment and limits operational effectiveness. For Chinese Special Operations Forces and forward air controllers who trained extensively with Type 06 systems, only to watch them fail during exercises and operations, the designators represent betrayal, leaders who valued political face over capability, an industrial system that produced equipment that looked right but didn't work properly, and years of degraded effectiveness while China's adversaries equipped their forces with genuine precision instruments. The story deserves remembering not just as a failed development program, but as a lesson about the costs of technological shortcuts, the importance of building genuine capability rather than copying appearance, and the human consequences when military forces are equipped with systems that inspire false confidence rather than reliable performance. The operators who aimed Type 06 designators at targets, hoping the systems would work properly, deserved better equipment from a system that valued capability over politics. Equipment that enabled precision strike as promised, rather than equipment that failed when precision mattered most.
If you enjoyed this video, make sure to like it and subscribe for more content just like this.